Hey everybody, so today's just going to be a short, quick little video because you've already been practicing with this stuff, but exciting stuff is that we're starting our chapter on linear functions and linear equations. The first part is pretty basic, it's just putting things into a table, so this should be something that you've already done in the past. But just for a refresher, remember that x, those are typically our inputs, which means that y, those are typically our outputs. So we want to know, okay, if we input different things for x, what comes out as our output for y? And this one, it says fill in the table for y equals 3x minus 5. So if they give you a blank table like this, you can choose whatever x values you want. Now, I would try to be a little bit smart about it and pick some x values that make a little bit more sense or that would be easier to graph. So the easiest one I think to choose first is 0, because 0 does a lot of nice things for us. If we plug in 0 for x, we get y equals 3 times 0 minus 5, which would just be y equals negative 5. So then our y value would be negative 5. Then what I would do from there is I would choose the next most obvious number, which would probably be 1. If I choose 1, I get y equals 3 times 1 minus 5. Y equals 3 minus 5, so y equals negative 2. So then my output would be negative 2 for that one. Then from there, once I get one positive number, I probably want to have one negative number. And that's not going to be as important now when we're dealing with linear functions because we know it forms a straight line. But when we get into other types of functions, that's going to be super important. So let's get in the habit of putting in some negative numbers now. That way, when we get closer to other types of functions, it'll make a little bit more sense. So I'm going to plug in negative 1. Y equals 3 times negative 1 minus 5. Y equals negative 3 minus 5, so y equals negative 8. Now, you should start to see a pattern that is forming in the table. On the left side, our x's have been going up by 1. And what's happening on the right side here? Well, you should notice that our y's are going up by 3. And remember, you got to be careful. Even though it looks like those numbers are going down, remember that they're negative, so you're actually adding 3. So if I were to do negative 2, I would be going this direction, so I would actually have to be subtracting 3. I kind of just gave the answer there. Subtracting 3 to get negative 11. And then if I wanted to do positive 2, I'd have to add 3 again, which would give me positive 1. So then in this table, I've got a bunch of sets of coordinates. I've got some ordered pairs. I've got negative 2, negative 11, negative 1, negative 8, 0, comma, negative 5, 1, comma, negative 2, and 2, comma, 1. And I could plot those on the graph. Remember that you go in the x direction and then the y direction when you are plotting points. All right, so in this one, it says to fill in the missing parts to the table. So this one you don't get as much freedom to because it already puts some parts in there for you and you have to fill in these missing spots. So in this one, it gives you some of the inputs, it gives you some of the outputs, and you have to figure out if you're inputting 0, what it goes to, and then you have to figure out, okay, what input gets me to an output of 0. So I'm just going to take this one at a time. I'm going to input 0 here, so y equals negative 4 times 0 plus 8. Y equals 8. So my y value is 8. And you should already start to see some patterns that are forming with 0 because 0 is our friend. 0 does a lot of nice things for us. See where you get that 8 from in the equation. That's going to be a reoccurring theme here. Maybe think about what this form is called up here. That might tell you a little bit about why 0 is special. All right, going to go to my next one. I got to figure out, okay, what input gives an output of 0? So I'm going to put 0 in for y in this one. 0 equals negative 4x plus 8, and then I'm just going to t-chart and solve it like an equation. So subtract 8, subtract 8, negative 8 equals negative 4x, divide by negative 4, and x equals positive 2. So if you input positive 2, you should get an output of 0. All right, I'm going to do the next two over here. I'm going to input negative 3. So y equals negative 4 times negative 3 plus 8. Y equals 12 plus 8. So y equals 20. Y equals 20. All right, and then the last one down here, we've got an output of 32. So where am I going to plug that in? I'm going to plug it in for y. 32 equals negative 4x plus 8. T-chart, subtract 8, subtract 8. 32 minus 8 gives me 24 equals negative 4x. Divide by negative 4, and x equals negative 6. So my input here is negative 6. All right, last example here. This one says to graph the line using a table of values. So in this one, it gives you the equation y equals 2/3 x plus 1. So now we're introducing some fractions in there. So we're going to try to make our lives a little bit easier because table doesn't have anything in it, so we can choose whatever we want in the table. Now, again, the first choice I think always should be 0. See if 0 would be a good choice. If I input 0, then that's super easy because if I put a 0 there, I'm left with just positive 1. So that's super easy. So I can go ahead and graph that point, 0, 1. Let's put some slashes on here. If you had graph paper, that would be great. All right, 0, 1 is right there. Then I'm going to be smart about my next points. I know I'm going to have to multiply by 2/3. If I choose 1, then I'm going to have a fraction in there. And I don't know about you guys, but graphing fractions on a graph like this is not fun for me. So I want to choose something where that fraction is going to go away. So I know that the denominator is 3. So I'm going to be thinking about, okay, multiples of 3 would help me get rid of that denominator. So I'm going to first multiply by positive 3. When I do that, I'll do it over here. Y equals 2/3 times 3 over 1 plus 1. Well, that just turns into y equals 2 plus 1, which is y equals 3. So then over here, when I input 3, I get 3 out. So 3, 3, 1, 2, 3, 1, 2, 3 is going to be right here. And then I'm going to do the same thing. I'm going to make my life a little bit easier. I'm going to choose negative 3 because it worked out so well with positive 3. So when I input negative 3, I get y equals 2/3 times negative 3 over 1 plus 1, which is going to give me y equals negative 2 plus 1, so y equals negative 1. So when I input negative 3, I get negative 1, 1, 2, 3, and then it goes down 1, so it would be about right here. Now I've got enough points where I can go ahead and connect the line. Make sure you put arrows on both ends. That means that the line extends infinitely in both directions. If you don't put the arrows on the ends, you're saying that it stops right there. And linear functions, they extend infinitely in both directions. So hopefully this made things a little bit easier. Make sure that you finish that Delta Math assignment. Let me know if you have issues with it. If for some reason it's not letting you plot the points correctly, just let me know, and I'll go in and look at it.